So we are recording. This is, what are we on, day 3 in the afternoon? Hi. A certificate, certification testing certificate. That's awesome. I want to start the afternoon. Yesterday we kind of looked at the Cisco IoT Connecting Things course. Today I want to look at the IoT Security course. These are all courses that, so I added you all to the instructor versions of these courses, and I didn't embellish any of the courses with any of the stuff that I normally would embellish. These are just straight what Cisco provides. And I wanted you to be aware of what's in there and kind of how I've used some of the materials and how you could potentially use the materials. Again, remember that these 3 courses, Connecting Things, Security, and Big Data, all have end of life of end of July next year. So you have a little bit over a year to use them. So pretty much 3 semesters. This semester was summer, spring, summer, fall, spring, summer again. But there's some really good stuff in there. And in fact, the IoT security course, of all of these courses, that's the one I'm the saddest about, going away or not being available. So I don't know. I hope they leave some of the components there, or maybe move them into, like I said, the skills for all kind of thing. But connecting things, like we talked about yesterday, I've been able to kind of rebuild it from scratch. I think we can teach a lot of the same topics and the concepts and everything without the material. Cisco for the security class, they did I think they did a really good job. I teach the IoT Connecting Things all the time, but the IoT security class is kind of like the funnest of the 3 classes. So let's go take a look at that real quick, see what I'm talking about. What do we feel like today? Course index, right? So the way this book is, or the way the work or the course is set up, right? There's chapter 1's the introduction, right? So the IoT under attack talks about IoT and then all the things that could go wrong with it, and we'll talk about the labs in a second. Then it kind of migrates into starting with chapter 2. Actually, chapter 3 is kind of where they start the pieces. Yeah. So, right. So they spend the first 2 chapters kind of building up to this, right? So we talk about the IoT under attack. We talk about systems and structure and architecture, like how IoT is put together, so that we could have an understanding of what we need to protect and how we need to go about protecting it. And then what I really like in this course is chapter 3, 4, and 5. This one's the device layer attack surface. So you actually, there's a lab in here where you actually connect to the pins on a Raspberry Pi, and you create a terminal session to the Raspberry Pi. So you can see how an attack at the hardware level could happen. The second part, chapter 3, chapter 3 has both firmware and like physical and firmware, right? So there's firmware attacks that you can go through and do. And then chapter 4 gets into the communications layer. So there's some Bluetooth stuff. There's an MQTT lab in there, right? So you get into the communications, right? How do we, can we encrypt things and not encrypt things? And we'll show you the labs in a second about that. But then chapter 5 is then the application layer. So then we start looking at, actually the MQTT is considered an application layer. My bad. But like universal plug and play. I think there's some things on, there's things on passwords and other things like that at that level, right? So there's really cool labs that I feel when you do those labs, like it takes the book learning that students know, I've heard about this and that, but you actually, when you do it for real, when you actually connect to a Raspberry Pi physically and do create a terminal session across serial, it's different than just reading about it and knowing that those kind of things happen, right? So you actually are doing quite a bit of the hands-on, like digging into the system. The course has a PL app that goes on the Raspberry Pi, so it has a Raspberry OS that's specific for all of these labs. It also has two virtual machines that go into a virtual box, Oracle virtual box. There's a Metasploitable OVA, and there is a Kali Linux OVA, right? They're designed, and you use both of those to learn quite a bit of different pen testing techniques and tools like that. So this was the kind of the first class that I've seen, and I don't teach the cybersecurity component of ours. I teach Security Plus, but not the hands-on components. But there's like a lot of hands-on things going on here where you're actually, using the tools to actually discover things and see things and go through that. Plus, throughout the entire, like starting in chapter 1, I believe they introduce a packet tracer lab, just exploring a smart home. So there's a packet tracer. I wonder if it shows, I think it shows us a picture. Right, so there's a packet tracer, and this is in the packet tracer, like this lab, and all of these components are all accessible and programmable and configurable. And from even then, starting in chapter 1, working, they introduce it in chapter 1, and then starting in chapter 3, you actually do a threat modeling based on this smart home. So I really like it from the perspective of students. Like if you were to give them an enterprise, like a company, like maybe they wouldn't connect to that. But if you show them a smart home, right? We all live in some sort of home, right? Apartment, whatever it may be, or it's something that they can, visualize, and then, so they have there's a connection there to a smart home, right? There's a connection to a living space and all these different components that are in that space, and then this threat modeling, has you think about those things throughout the entire course, right? So you introduce to it in chapter 1, and then chapter 3, you do threat modeling at the device layer that matches the labs that you're doing, the physical the physical device layer labs that we're working on. Then you do a threat modeling at the IoT communications level in chapter 4, which is where we're doing, pen testing on the communications layer. And then you have IoT at the application layer, and that's where we're doing attacks on the application layer. And then finally, at the very end, you actually do a risk assessment, right? From threat modeling to risk assessment on that entire system, all in Packet Tracer. And there's each of the labs has charts and forms and things like that to kind of build up your knowledge and ability in that space. So it's one of the few places where I've seen where it's something it's a project that lasts throughout the entire semester, but it fits in with everything else that's going on. So I really like that from that perspective. So that's kind of those pieces are really, like I said, I'm kind of sad those would go away. The labs, right? So the regular labs that are in this class, right off the bat, we show them Shodan. If you've ever never seen Shodan, you should go check out this lab. But it really, a lot of these things are eye-opening for people, right? They've never, they haven't ever seen these kind of things, and then we're, showing them all these really crazy tools that are available. So when they do Shodan, I also like to show like Wiggle and router password websites, so they can understand that, pretty much if you leave anything default settings, you're leaving yourself vulnerable to whoever, right? And then, right, so there's a couple of, they do evaluate some home automation products. So they got to do like a research project. If you have a couple $1,000s, go find some really cool products and share those with us. and then some other evaluation things. But then you start getting into the hardware labs, right? So you got to set up the PL app, right? Like I said yesterday, there's always in all of the IoT classes, there is a set up the PL app on the Raspberry Pi lab. And then this one has the IoT security lab topology, which is setting up VirtualBox and downloading the OBAs and getting the virtual machines up and running. And then there's actually a lab on how to harden the Raspberry Pi, which I think that lab can be used in the IoT class, is hardening the Raspberry Pi, but it actually, you go through and at the terminal, right, you do, yeah, be careful when you're doing this one, right? You add users, right? So you choose the kind of some basic Linux things on how to add users, setting up SSH, right? Those kind of things. So that's really fun, kind of go through that lab to get a sense for how to make the Raspberry Pi a little more secure. You can also set up the uncomplicated firewall. So they have you walk through that and do a couple real tiny, small things. Right? So you can start to learn how that works, right? So I really think like this lab could be used pretty much anywhere where you want to have them, learn about what a Raspberry Pi can do. So this is a really cool lab from that perspective. Right? So a lot of these, like this one, I'd want to maybe yank out and put into a different class, right? Or duplicate something like this so that you have this kind of learn how to harden the lab, how to set up the uncomplicated firewall component there as well. So I think those are really cool. And then the last lab is just like go into Kali Linux and look at all the different tools that are there. Yeah, so it's pretty cool stuff. So the first lab's first chapter is just getting you set up, getting everything working, and then you do some hardening of the Raspberry Pi to start getting a sense for what this class is going to be all about. I'm pretty sure there's courses or online materials for WordPress. I haven't ever, other than what you saw today, that's about the extent of my WordPress knowledge. So yeah, I'm sure there is. I just don't know. I'm answering the question. All right, so then going into chapter 2, right? This lab here, create an IoT sensor actuator. I've actually pulled this lab out of the security class, and I have this as one of the labs in my IoT connecting things course. So this is going to be, you have a Raspberry Pi with 2 LEDs, okay? We use the PL app launcher to connect to this to do the coding. Then we go out to IFTTT and set up an account. We go out to Dweet and set up a URL. And then we connect our cell phone to IFTTT. We actually put a button on the cell phone, like you can press a button on your screen, which triggers the change of lights. So this is one of those that I figured, in the security course, it's kind of showing you how it's not really secure, right? The idea of this is not really secure. I moved it to the connecting things course because first of all, we don't teach the IoT security course using this format. We have, we don't do IoT security. We just do security. However, I think this is a really good, like, early internet connectivity lab, right? Where you're connecting a smartphone to IFTTT to another to Dweet, right? Which is then the Raspberry Pi is watching Dweet and you controlling an LED with your phone, right? Which I think is a fun project to do. So I've pulled this one over, and I actually go into, in order to do this one, we actually have gone to the, let me go back here. So I've gone into the set up your Raspberry Pi, right, as a PL, and then in the lab, the latest version of Jupyter Notebooks. So when you go here, right, so here's the image. Oh, this is interesting. So when I went to it from here, it just has the image and the but remember yesterday when we clicked on that kind of stuff, let me do the PL app launcher, see if it goes to the big files. it doesn't. Okay, so IoT security is not going to the same place. But what I've done is I've actually pulled, and I think instructor materials has it, but I have pulled the Jupyter notebook, right? The student Jupyter notebook. I pull it out and I actually attach it to my assignment in my class, and I walk them through downloading it and uploading it into their current Jupyter notebook, their current PL app server. So so the lab is there, and I think all the pieces that you need for it are already there. So we didn't really have any problems with that. So that's, so that lab, like I said, I pulled out and put that in the IoT class because it's another, sequence of things. You included a phone, the IFTTT, DWEETs, right? Physical computing, all in one simple project for chapter 2, okay? And then chapter 3, compromise an IoT device hardware and compromise IoT firmware. So the IoT device hardware, that's where you're gonna do the physical connection to the pins and do the terminal using serial cable. So that's I really like that lab. I like the idea that you can show them how you can physically connect. And then the IoT device firmware, they give you a firmware that's been pulled, and you use the software that's in Kali Linux to mess with that from a lab perspective, right? So this one right here is one of my favorites. In chapter 4, right? So there's a sniffing Bluetooth, right? So we actually can sniff Bluetooth. I think we connect, because there is Bluetooth on the Raspberry Pi, right? So you can snip the Bluetooth, and then we can actually connect devices to the Raspberry Pi with that. And then there are some port scanning and packet crafting components that use the virtual machines. So there's some pretty cool stuff there. A lot of this is like hands-on. It's one of the things I like a lot about it. Like, you actually have them do things instead of just talk about things. Then the next one, right? So there's a challenge passwords with Kali Linux. There's a web application vulnerability lab that you do. There's a hacking MQTT lab, which I almost want to move that one over to the IoT course. Mainly not from the hacking perspective, but just setting it up and getting it working. And when they say hacking, what they do is we actually set up an MQTT infrastructure, right? So that's there's 3 Raspberry Pis involved in that. There's like a publisher, subscriber, and a broker. I think those are the 3 pieces. And you pass information back and forth, and you can see that it's, by default, it's just plain text information. And then where we ran into the problem the last time we ran this lab is that we couldn't get the encryption component to kick in. There was some change that was made between the instructions and the actual operating of the actual MQTT network. So that's I'm looking at I stopped to look at the comments. So that was good. And then there's a universal plug and play vulnerabilities lab as well. So I think what I'm trying to get at on this one, like, it's full of these hands-on, like actually doing, different things to see the results of those, so that your students gain a better understanding of the system, right? Of how this works and how hacking works and that kind of thing. And then the final chapter, right? So that by the time you get to chapter 6, they're fully into that course-long vulnerability and risk assessment. We introduced them to CVSS and DREAD, and they actually build out in their as part of their packet tracer assignments, they build out a vulnerability and risk assessment for the entire for that project that is lasting the entire semester. Okay, so I really, I think there's a lot of cool labs here. I think you could pull some of those out into your regular class. Like the Showdown search is just a lab that works anywhere. You don't need to be, you don't need to have a Raspberry Pi to do that one. There's another, I don't know where it is. there used to be another lab. I don't know if it's here or somewhere else. There's a lab called Where's My Data? I don't see it here. I'm drawing a blank as to which course it's in. It should have been here. But there's a Where's My Data lab that I thought was really cool because it it has students go and actually read the EULAs of some of these, like Facebook and Instagram and whatever, and answer questions about who owns the data and what can you do with the data and like all these crazy things, and this really big eye-opening assignment for them to go like, what is going on here? Like, so when they just randomly just say okay because I want to play this game, right? There's lots going on in the background. So just something to be aware of. I think it's a really cool, and I got to find that one, that lab. But in this class, right, as part of the Cisco curriculum, I like it a lot because there's lots of hands-on. They've got this project that lasts the entire semester for doing a risk assessment. And so as you learn each piece, you add more to the assessment and more to your understanding of the overall. Yeah, I don't know, it's good stuff. So that's that course, IoT security. I think if you're not teaching an IoT security course, you could pull some of these labs out and move them over to another course. If you have the PL app running like for the Connecting Things course, you can grab the latest version of the Jupyter notebooks, and like I've done, I've attached, I'll show you what I'm talking about. I've attached the the notebook to the assignment. So I think it should be here. So there's the Twitter assignment. Let's get gooey with it. Initial state, that's the health, that's the health system, the board we were doing yesterday. Here's the create a sensor actuator assignment, right? So I've done a video for that one, but if you click on the lab, right? So here's the actual, one of these is the instructions, and one of these is so this is the notebook. So they would download the notebook, and then they would upload the notebook onto their PL app, and then be able to use the notebook as if it was part of the class. So that's how I've done it for my class. All right. Any questions on the security? Is anybody using or teaching IoT security this course, this particular course? All right. So anyways, yeah. So I think there's lots of good stuff there that you could use. That would be beneficial, right? If you're not teaching that class, I think I've started pulling some stuff out of it that I think could be nice to have as labs and other things. So as long as you have the PL app use it, on a Raspberry for the other class, you should be able to do that. All right. Okay. So at this point, I'll give everybody a couple minutes to. We probably need to redo another SD card with the legacy OS on it. Right, so I'm gonna let you do that. I need to step away for a second. So if you want to get a legacy OS card up and running, and then we will work on building a Python web server with Flask. I'll be back in like 2 or 3 minutes. Give me a second. Sorry about that. When my kiddos showed up, they needed a Costco card. Okay, so in order to do that project, I'm going to move this off to the side. We need to, I'm going to start with a brand new machine. The other thing I want to do is I'm going to do VNC, and I'm going to connect to 135. Where is this not in order? So this 135 is my actually, I wonder, I'm not gonna actually, I'm gonna choose a different raspberry. Like I don't have the I want to avoid the whole having to do get rid of the main host. And I have enough, so let's see if we can get this one to work. All right, so let's do that. So I'm gonna go ahead and I'm gonna leave that one. I'm gonna leave that one alone. I'm gonna leave that one alone. I'm not gonna touch that one. And I'm going to, so we're gonna choose an OS, Raspberry Pi other. We're gonna do legacy. At this point, I'm just gonna grab random SD code. Let's see what I just did. All right, settings, we're going to call this one 3, enable SSH, Raspberry, set the local.
And I'm sorry, which one are we picking? Which version? Light? Legacy?
Legacy, just the regular legacy, not the light.
The same legacy, okay.
Yeah, the same legacy. We're just gonna, I just want to do it on a different machine so I don't have to get rid of the website that I just spent all that time creating. I know it seems silly. And then I grabbed an 8 gig SD card. I'm not keen on using an 8 gig. I think if you have a light version of the OS, an 8 gig's not going to be an issue. I never know with the size of the GUI. Right, so it's a 31. So okay, so Raspberry Pi legacy, Raspberry Pi OS legacy. Okay, and then set your. So I just changed. I got the host name. It's I've got the password. I got SSH. I've got my locale set. I'm good with that. I'm going to go ahead and write this. And while that's writing, I need to grab. I'm going to grab another power cable so I don't have power issues on this one. So I'm going to set my mic down and I'll be right back. All right. So for my network, because I'm teaching, I try to do this, but I have a little Netgear 8-port switch on the desk. I've got that connected to my regular network. I've got some shorter Ethernet cables attached to the switch by default there, so that I can just I'm ready just to plug them in and do my thing. In fact, what I probably should do, let's. So a little behind the scenes, right? So you see all the mess behind me. Like that's why I always have a background on. But so right, so there's the computer I'm working on, right? All the lights and stuff. But then I've got this is the web server. This is the AdGuard server. This is going to be the new web server that we did. But so I've got a Netgear switch back over here. And then I just kind of have my stuff piled at this point. So I got extra raspberries, all my SD cards. I got a box of books down here. I got actually 2 bins full of those magazines. Like I could have pulled out, we could have spent all morning just going over the magazines. And then this is what my kit looks like now. So I've got these 3 boxes, right? So this really big one here has my Raspberry Pi tops and everything in it. And then I've got a Pi 400 in there, and then I've got cables and things in bags. And then I've got this little cart back here. So I've got everything in this one dolly based thing. Everything fits in there to make this easier to deal with. Just so you kind of get a sense of like how I'm doing it in the background. I keep all of that off to the side on the table so that I can get to it quickly while we're doing these projects and stuff. So I have a castle. What do we feel like doing this afternoon? Here's what we want to. Here's where we would prefer to be. I enjoy doing this, but man, if I have a choice to be there. So, all right, that's good. So I'm writing, I'm verifying at 25%, so that's pretty good. So end of the lab. So Tim, I'm assuming at the end of the last lab, you rebooted the Raspberry Pi and I can't get it back. That's not good. Did anybody else have that problem where when they did that reboot at the end?
It's, I just move on to the new stuff. I will probably just redo that all over again.
Okay.
But I was able to finish the whole thing successfully. So
awesome.
So that's not the issue. But the issue is like, I don't know what happened,
Right. Yeah. You're like, what's going on here?
It could be like, I think it's a little bit older. It's not one of the newer one I had.
Okay.
You'd have a problem with the SD card or something like that.
All right. So that looked like that finished. So we'll take that out. We'll see if we can get it to boot here. Power it and connect it to an Ethernet cable. All right, so it looks like I've got flashy green light, so it looks like it's loading properly. That's good. Excellent. Let's fire up a new terminal. Where's this one connected? This one's connected there. So ping. What's 3, right? Oh, it's not on the network yet. I always close down the Pi imager too fast because I can't go back and check. All right, so I'm getting a reply. I'm getting a IP version 6 reply. I seriously have to turn that off. I don't know why I even have it running. By default, I mean, That's what happens when you leave things default. Don't leave things default. Okay, so 106 is where my new Raspberry Pi is at. So SSH Pi at 172.17.69.106. Yes. Password. And we are logged in to the Raspberry Pi. We can do a sudo raspi config at this point to kind of do the basic systems. I don't need to do any of these items, right? I've already done all of those, so I'm good with that. And then display options. Let's go ahead and set the resolution. And I found that 35 works fine, or even like 82 is fine too. So 35, whatever works on your monitor. I'm going to do this one. Interface options. On interface options, right? SSH already is turned on, but we want to turn on VNC. So we're going to highlight VNC, hit enter, change it to yes, hit enter. VNC is enabled. Localization. I don't like doing localization this way, right? So I'm not going to mess with localization here. I'm just going to cancel out of that part. And I don't know that there's anything else that we need to worry about. We used to have to expand the file system, but that's done automatically on first boot. So we're good there. All right, I think we're good. I'm gonna go down to finish. So I turned on VNC if I need it. I'm not gonna mess with trying to get to VNC unless we see that we're gonna have to get there from here. But this lab, which is listed in the links to the labs on the last page of our web references document, is building a Python web server with Flask. So just going to build a web server using a different way to build a web server, basically, right? So kind of expose ourselves to different ideas, different thoughts. And I want to look through it. I'm thinking that a lot of it's going to be I think we're going to be able to do everything from the command prompt. If we can't, then we'll switch over to the VNC, but I think we'll be all right. All right. So we'll pause, make sure everybody's good. Has a new legacy box set up. So actually, while we're here, let's do this. I am actually going to connect remotely, but not for the purposes of the lab. I want to. Oh, did I not? I thought I exited out properly. Or did it reboot on me? I think it rebooted because I changed things. And it's not back yet. I think I may have missed something up. So I'm not worried about that. What I'm worried about is this one. Enable. So yeah, that didn't drop me out. So I did something that, I changed the resolution. Oh, and it's not 102, it's 106, right? And that's why I can't find it. Okay, sorry. All right, so Next, this is where I'll change the localization. This is the only, like, I like this part as far as the graphical interface, but it seems like we can get away with, there's a way to do all of this on the, in the terminal. Nice. Not gonna do a new password. Screen's fine, skipping the network, skipping the updates, we're done. Okay, what I want to do here is on the Raspberry Pi here, if you go to the menu and you go to not preferences, accessories, there is this SD card copier, okay? So SD card copier, right now, if I click on the from device, it's gonna give me this SD32G, right? MMC, this is the actual device that's connected to the Linux server. There is no copy to device because I have not plugged in the SD card reader, okay? So this way I just know, I know where I'm coming from. And this is the SD card that's in the Raspberry Pi, okay? Now, so I'm gonna select that, but then now I'm gonna plug in the SD card reader that has another SD card in it. I'm gonna plug that into the Raspberry Pi. Maybe. It's like one of those USB, have you ever seen the meme where they plug it in one way, plug it in the other way, and then you go back to the original and it works? So now you can see I have a Sabrent plugged in as well. So from my SD card that's in the computer, in the Raspberry Pi, we're gonna cancel out of that. And then to the Sabrent, and then I'm gonna hit start. We're gonna erase everything that's on that drive. So what's going on now is on this computer that we're working on, this new computer, it's creating an exact image of this working OS, right, on another SD card. So then I have a copy of that SD card. So if we're going to do another project and I want another SD card, then I can simply plug this other one in, and I don't have to worry about any other configurations or settings. Okay. The problem with that is that this is going to have the same name, so I'm going to log in, and then I'm going to want to change the names and things like that. But that's a minor inconvenience compared to having to re-image the thing every time. Okay. So I'm creating a copy using the SD card copier, right? So from a system administration standpoint, from a proper techniques, right, for taking care of computers, having a backup copy of your operating system is a good thing. And I have my students buy an extra SD card specifically for this purpose, right? They actually have to buy 3 SD cards, one for the Raspberry Pi OS, one for the PL app, and one for a backup of the Raspberry Pi OS. I believe we could probably make, using DD, we can make a backup copy of the PL app, but it's not something we've done. I'm going to let that run in the background, and we don't need to be watching that. Like I said, we can keep on doing other things. I am logged into the machine here, and I'm going to go ahead and start this Python web server with Flask. Okay. If you have to create a lab full of computers, right, then the SD card copier will save you a ton of time, because what you basically do is you set up one computer exactly the way you want to. Do all the updates, add any software, add any files, add any file structure, anything that you want to be on there. And then you can use the SD card copier to copy it any number of times. Okay. I normally, when I'm doing that for workshops or labs, I'll have 4 Raspberry Pis connected to monitors, or 4 Pi tops or whatever. I'll have them on the dining room table. I'll start with one, and I'll get it right exactly the way I want to. I'll make a copy. I'll put that copy into a new machine. I'll boot it in the new machine, and then I'll make 2 copies of both of those at the same time. And then I take those copies and put them in the other 2 machines. And then I make 4 copies. And then I make 4 copies, and I just kind of walk from machine to machine. And as each machine gets finished, then I pull those off, and I have a lab full of computers. So, and like I said, I think I said this the other day, it usually takes me a baseball game to get from start to finish. And that's starting with the installation, doing all the configs, right, making the backup copies, and then rolling those out. And I'm not sitting at the machines the whole time. I'm usually going during the breaks between innings to do all the work. So anyways, yeah, just again, a technique that I use that maybe you may find useful. I don't have access to a multi SD card reader writer thing, so we do it that way. All right, so let's get moving. Build a Python web server with Flask. This is kind of, yeah, this is going to be like me right here, my website. What we need a computer running Python 3, and we need Python 3. So we have Python 3 already. And this shows you how to get it, right? And this is saying you don't need a Raspberry Pi to do this. You can just any computer, right? What we're going to learn, how to install Python modules using pip, how to build a basic website using Python and Flask, okay? So this is another thing, and if you explore kind of the stuff that Raspberry's done, they've actually gone out and they've put together, you know, learning objectives, and they created these structures for you to kind of, you know, if you wanted to kind of make sure that the student learns everything you need to learn. There's lots of really cool. Let's go look at it real fast. What I'm talking about. But, so design, programming, physical computing, manufacturing, community, and sharing. So they have these 4 different things. You can create curriculum for creator, builder, developer, maker. And then within maker, right, there's example outcomes, example projects, right? So design multiple and integrated assets using for use in complex finished projects and modules. Right? So they've given us some structure, right? So I think this is going to, again, not a community college level structure, but it's, I think, some fun things that you could, for middle school and high school, you can build around those. They probably match to, a lot of it's going to match to computer science curriculum and things like that as well. So just something to be aware of, not overly important in the realm of what we're working on today. I'm not worried about installing Python 3 because we should already have Python 3. We also need the Flask package. So that one for sure we need to install Flask Python using pip. So if we click on this little box here, it's going to drop us into like a submodule here, pip or pip3. So we're going to use pip3 install the name of the module. So the name of the module that we need is Flask, right? So we should be able to do this with a sudo pip install Flask. I wonder if we should do pip3. We should have done pip3. Already satisfied. So Flask, that's Python 2, right? So pip is going to be Python 2. Okay. We do pip3 and hit enter. So we already have Flask, right? So Flask is already installed. So that's good. But they do, I think this is interesting because they do tell you that you can use any computer that has Python 3, right? So if you have a Windows machine, you can install Python 3. And then down here, they give you, the different ways of installing on the different operating systems, right? So that's why this one's a little different than, say, if they're going to say you need a Raspberry Pi to do this. This one, they're not saying that. So let's see. Once we've got that, open Flask is installed. Once Flask is installed, you create a web application. So open the terminal at the command prompt, make a directory, create a directory called web app. Okay. Where am I at? Oh, I am. So I'm in my home directory, so that's good. mkdir web app. And then we're going to go into web app in the CD space web app. Open Python 3 idle. Create a new file by clicking on file. New file. Do we have idle on here? Just do Python 3. Yeah, so we can do it here. No. So the way they've written this, so this is different, written different than the other one.
It looks like you probably missed a step. You'll need to do a sudo apt install idle.
Yeah, yeah, maybe up here, right? Well, if you install Python 3, right, it usually installs idle.
I think under the, if you scroll down to the Raspberry Pi directions, I think it includes, to install Python 3, which you already have, and then also idle. There it is.
Ah, there it is. Okay. Okay, so then we need to do that. So let me, is it a Q, right? How do we exit out of this? Exit. No. Okay, there we go. Control. I'll use exit. All right. So we do need to do that. So I went back into the Python installation, and we're running this last command there in the box, the install. I don't need to do Python 3, but I'm going to do idle 3 so that I have idle available to me. Idle used to be the default IDE that you would run on a Raspberry Pi, and then they, at some point, they switched over to Thonny. So Thonny is the kind of the new default. So then at this point, I should be able to just. Oh, does it need to be a graphical interface? Yeah. Okay, so then, yeah, if we're going to use that, then we definitely need to be running VNC. I'm happy that we are running VNC already, and that we did set it up. And then from here, now you can see we have idle already installed here. So we could have probably just used Thonny from the graphical interface. So for those that don't have VNC up and running, I'm going to pause here to let you get that done. I'm going to go ahead and I'll fire up idle. If you're at a terminal and you want to get, and VNC needs to be set up, right? It's going to be sudo raspi config. There's the command at the bottom of the screen there. That'll bring you to this menu. You're going to go to interfaces, number 3, go to VNC, number 3, and then just hit enter on yes there. So highlight yes and hit enter. Then obviously connect to your graphical interface. I'm sure we probably could have created the program in Nano, right? We could have just created a program in Nano and done it at the terminal.
I cannot find the version when I try to install the module, the pip module, using the pip command.
Is it giving you an error?
Could not install packages due to environment error. 404, basically the website not exists.
So sudo pip install flash. So is that where you're getting the error?
Yeah, exactly.
And you add a command prompt, you can ping like 8.8.8.8 to make sure that you have internet connectivity.
Oh,
Just making sure. I'm curious.
yeah, I think I got update from the Yeah, I think I have a network access and internet access.
Okay. And then what's the error that it's given you here?
Could not install packages due to an environment error. 404 client error.
That's
I
right.
think
Are you running sudo pip install or sudo pip3 install?
I tried to run both.
Okay, and they both gave you the same error?
Yeah, not found. I think I got 404 error probably the.
And so pip is it's odd that you're getting that. Is anybody else getting that kind of error, the 404 error? Which means like there's nothing there, like it's going to the wrong place. It's that seems odd that you're getting
Yeah, it got in the document. It talked about that. Could not find a version that satisfies the requirement. Then we can do some other thing maybe.
okay. And that is
Let's see.
this one here. Troubleshooting. Couldn't find a version that satisfies the requirement. It's a misspelled package name. You're using all lowercase for.
I kind of copy the Linux command. I completely paste it there.
Oh, are you? So name a module. It needs to be Flask. Did you
Oh,
change
okay.
that?
All right. Okay.
Yeah. So then it's sudo pip3 install Flask. Flask. All lowercase.
Yeah, I think that solves the problem. Great.
Okay.
Thank you.
Huh? No worries. No worries. Okay, so that's nice. So there is some troubleshooting down here that helps us. And then upgrading some packages. If you have packages that you want to upgrade, you can install upgrade. But at this point on this machine, right, we've installed. Yeah, I kind of want to stick to the terminal here. So what I'm going to do is close these. All right, so that's how to install Python. So from Python, we installed idle from there, but I'm gonna probably just use nano to do this, I think. So then once this is done, we install. All right, so that one's done too. So we've done both of those. And then open a terminal, make directory, we've done that. And change directory, we've done that. Open idle3, file, new file, save the new file as app.py in the web app folder. All right, so if I am in the web app folder, right? So pwd shows I'm in the web app folder. If I do sudo nano app.py, then I just created that file in the web app folder. And then we want to put this information over here. That's too long for me to type. From Flask, import Flask, app equals Flask name. Okay. So now enter the following lines of code into the app file. Okay, you explore this code in more detail in the next step, but first make sure the code works. So then I'm going to go ahead and save this, right? So then Control O. Whoa, I'm on the wrong computer. Control O, enter, Control X, and we want to make sure that this code works. So to run the app in the web terminal prompt you opened earlier, what's gonna look like your code? If your code is correct, the window should show you the following output similar to this. Running, restarting, debugger is active, debug pin code. Okay, so let's see if that happens. So Python 3 app.py. Okay, so this is, they gave us this here. Okay, import Flask, we have the name, app route, right? Return hello world kind of thing. Hit enter. Do not use the development server in the production environment. Thanks for telling us. But we're seeing what we're seeing what we're supposed to be seeing, right? This right down here, running. So here's running, restarting with stat, debugger is active, debugger pin. Okay. Awesome. This other stuff here is because it picked up that we're running. So open your web browser and enter the URL. So at that point, like I can, well, we're not going to do 001, right? We're going to go to the IP address of that computer because I'm going to do this from my PC, right? So it was HTTP, right? Yeah. Forward. It's 172.17.69.106, and I believe we're using port 5000. Is that the port? And I got a hello world. And then it also says right here, right? We got some communication going on. All right. So awesome. So we have installed Flask and have a web page up and running. Not a big web page, but it's up and running. Okay, so that's what we're looking for. Awesome. To add a new page. Now we're going to add a new page to our web app by creating a new route. This thing kind of, they call it a web app. So it kind of starts to think like, I wonder if these things, like these would be perfect for like running in containers, right? Some kind of a Docker kind of a deal. All right. So if your in your code, you already have in app.py, there's a single route. This route is made up of 3 parts, right? So the first line determines the entry point, right? The slash means the root of the website. Right, so this, right? And then def index, right? So it's a definition. This is the name you give the route, index. And then return hello world is the content of the web page. Okay. If the second half of the app code runs the web server and your app. So this is, that's the part that runs the web server. Cool. So it's nice that they explain like this. This right here says anybody on the network can get to this. Following instructions shows how to create a new page and route called cakes. If you want, you can change the name. No, cakes is perfectly fine. To create a new page and a route to it, add these lines of code below where the first page and the routes are created in app.py. Okay. So I've got my web server running, right? And it's taken up my terminal here. So I'm going to switch to another terminal. Log in from there. And so pwd, I need to cd to web app so that I'm in the right place. ls, you can see the app.py is there. And then I can nano, sudo nano app. Okay, so here's my still trying. So did you put the colon and the 5,000 on the end?
Yes.
All right. So one or the other thing is I didn't add the little the forward slash on the end of that, but it's supposed to, it's typed in that way, but I didn't type it in that way, like right here. And you're using the IP address for the machine that we've done this on. Not the 127.
Yeah.
And your app.py file looks exactly like this.
Yes, it does. I'm just laughing because I keep muting and unmuting myself.
We're gonna go double check everything. I'm like thinking through like, okay, so if it's not loading, it should be loading. There's no reason why it's still loading.
Is there an error message?
Nope, just a circle.
That's weird. Do you have a VNC connection to the machine?
Yeah.
So on the VNC, like, can you open the browser and do the 127 and see if?
Yeah, I have it both like on my host machine and on the VNC. And when you say 127, so for example, mine it's on Wi-Fi, so it's 10 dot something, right? That was like what you were asking earlier, making sure it's the IP of the Pi I'm using.
Yeah, like, so my IPs are 172.17, so you have a 10 dot something. But if you're on the actual Raspberry that has the web page, you can use the home address, the 127 address, right? So 127.0.0.1 points to the computer that you're on. Oops, and then we need colon 5,000 to get the same, right? Like it literally is only handing you 2 words. I guess there shouldn't be any delay. So there's something, I don't know what the something is at this point, but that's, and you could type out, your address 10.0.0 from this, and it'll work just fine. 127.0.0.1 just as it points to the local machine. And so Heidi's saying sometimes you just have to, there's a stop, like this turns into like a little stop icon. You can hit stop and reload the page. Maybe that will help refresh it. That's another option.
Yeah, I tried that, thanks.
Is anybody else not getting the web page to show up? Or having issues
What
at this point?
package are we supposed to install other than the GUI 0?
No, Flask. You don't need GUI 0. All we need is Flask. It
doesn't show that in the steps, does it?
Well, it does, but you have to. Here, let me show you what I'm talking about. Let me go back. Why are these arrows not on the top? It should be on the top. So build a Flask website. So right here, installing the Python modules. Install the Flask Python module. Let me undo this check mark. Using the pip command, right? So installing Flask, like this is what we need to install. What they've done here is this is an example of what you're supposed to do. Here's an example of what the code is supposed to look like. Here's an example of us installing GUI 0, but what you want to install is sudo pip3 install space Flask. Flask. That's all we need to install.
Okay.
This is one of those, yeah. So this one, this one is an older. This is an older one because this is back when they really were trying to get you to stretch out to understand. Right? They're like, well, this is what we want to install here, but here's how you would install any kind of module, right? And they could use this example in like 20 different labs, right? Or in 20 different projects. And all they have to do is tell you up here what actual module they want you to install. So it does get confusing, and you'll have students that do the same kind of thing. It's like, well, I copied this code, right? And name of module is not what we're trying to install, right? And then in the video here, GUI 0 is also not what we're trying to install. Way back at the very beginning, Like this is the only thing we're trying to install, Flask. All right, does that make sense?
If you install GUI 0, install Flask and like 10,000
Yeah.
stuff.
Right. Yeah, GUI 0. Like, yeah, we're not doing anything. GUI 0 is it's actually GUI 0 is pretty cool because it's a Python library that allows you to like do GUI, like to build web or boxes and put pictures in and buttons and all kinds of really fun things. It's what we use. I think the assignment that I have in there, let's get GUI with it, right? That uses the book, the Python GUI book, and that uses GUI 0, which is just a library for, there's multiple libraries that allow you to use Python to create GUI graphical interfaces. I just use Py0 because it's pretty simple. Okay, so we've done the hello world one. Sorry, I need more copy. File save, we've done run the app. Hello, oh, I'm on the next page already. We are here, what we're trying to do here, create a new page. So I'm on add a new page section of this, right? And what we want to do is we want to add a new page, right? So it tells us, I believe, we just insert this here, right? So app route, that's root, and then app route cakes, and then yummy cakes. Fair enough. And then on this one, like, so this is where, again, like, I don't know, this one is not as smooth as the last lab, right? It's just not, right? They have these little down arrows. Here's what the code is going to look like when you're done, right? So technically the students could just copy that over, right? But hopefully they do this and then they shows the code. All right, so once that's done, I guess I'm gonna go Control O to, whoops, oh my gosh, Carrie. All right, Control O, Enter, Control X, right? And then, like, I have it running in the background over here, so I wonder if I need to Control C it, and then I'm gonna rerun it, right, with the new web page, okay? And then if I go over here to this and refresh, I don't have, I see that one page, and then if I were to / cakes, right? I think that's how it looks. Yummy cakes. I didn't get dessert. We should take a break. Sorry. All right, so yummy cakes, right? So by doing cakes. So I'm here on this add an extra page. So we're using, right? So this is actually, so this website, right? Using app.py. This is a Python-based website. We're actually programming the website using Python, okay? And so far, if we look at our code here, this is our code, right? Import Flask, okay? The name, right? This is what the app is called this. And I'm sure, I'm not a Flask expert, but I'm sure that there's a reason for this. And then this is, right, this is that entry point. And we told it, right, there's an app, there's a route, and it's the home page, right? So if I were to just go to, this page, right, if I go here, right, with the one, :5000, the IP address :5000, that's going to take me to the index page, that entry point, right? And if I wanted to go to a second page, right, I would need to put the name of the second page out there, which matches this route here. I'm assuming, right, for those that have done this or that do this on a normal basis, I'm assuming that there's a way for us to put like a menu that allow you to then click on each of the pages individually from every page. But I don't think we're going to get that complicated today. All right. Okay, so I've got a web page and I've got two pages. I've got my index page that says hello world, and I've got the cakes page that says yummy cakes. I'm running 2 different terminal sessions. One terminal session has the actual web app running in it, and the other one has the terminal for me to do my work in. Next one, we're going to use HTML. So returning HTML pages. So next, you modify your existing routes to return a full HTML web page rather than just simple text. So HTMLs will be created from a template that holds the static content of a page. In the later section of the project, you'll learn how to insert data and create dynamic version of the page. So we need a templates directory in your web app directory. So it looks like from the prompt that I'm in the web app directory. We're going to do pwd to make sure that I'm in the web app directory. So I am. We're going to make a directory called templates, not template. We'll just leave it. I've got 2 directories. Templates with an S. Create a new file in idle by clicking file, new file. Save this file as index.html in the templates directory. So I'm going to go into CD templates. I'm going to go into that directory. And I can see from the prompt and I can see from the pwd command that I am in the templates directory. We're going to do a sudo. We're using nano here so that I don't have to use a graphical interface. Sudo nano index.html.
You don't need sudo there.
I don't? Okay.
No, it's everything's owned by PI.
Oh yeah, that's right. Thank you. All right, so index.html in the web app /templates with an S directory. And then here's the code that we're going to put in. So for those that teach or do HTML, it's HTML code. HTML body header 1, right? So close the body, close the HTML. Got it. Save your changes. That's all we're going to do. My website, awesome. We are getting super fancy. From Flask and what? Okay, let's do this over. So I saved that.
Right. I get now finally it works. I get the hello world, on the screen. So what is the next thing that you're doing now? Kind of lost you a little bit there.
All right, no worries. So what we're doing, we're just kind of working through the exercise.
Okay.
Let me.
You can just go back and follow that, right?
Build Flask. We're on this one here. So what you just finished this one, I believe, web app, and did you do this piece here with the hello world?
Yeah, that all worked.
Okay, great. So then I'm going to go here. Yeah, just go to the next. Well, I'll just throw this in the. So here's the next step. So in that link there is going to take you to this. So you're going to add a new page, right? So you're going to put this code into. I'm sorry, not that code. You're going to put this new yummy cakes code. Here's what the code is going to look like. So you're going to reopen that web app or the app.py, and you're going to put this code in between app route with the / and if name down here. So just put it there. Okay, and when you run that, once you run that, you can go and you can add the word cakes / cakes, and you should get yummy cakes.
Okay, got it.
All right.
All right. Thank you very much.
No worries. And then you're caught up because that's where we're at, right? Make a directory, HTML.
Okay, cool.
All right.
I'll do that.
Cool. So once you make your directory templates for this next step, right? So you're in the web app directory. You're going to create a templates directory inside the web apps, and then you're going to I change directory into that, and then I created using nano, right? Sudo, I use sudo, but nano index.html will create an index.html page, and then you're going to copy this code into that file and then save that file. Okay. So then we want to return to the app.py file in idle and modify the first line of your code to import the render template function from Flask module. Okay, so what we're going to do then is I'm going to go back to my page that's running the app, and we're going to Control C the app, and we're going to, from here, I'm going to modify the app.py because I'm in that directory and I've got everything here. So from Flask, import Flask with a capital F, and then we're going to do a comma, and we're going to pull in render underscore template. Okay, so that's just going to pull right from Flask, the library Flask. We're going to pull in the class Flask and the class render template because we're going to change some things down here to utilize this render template. Finally, modify the index, right? I believe modify define index here to return the render template index.html, which is what we just created, right? So instead of returning hello world, when we run this app and we hit the browser to that web page, right, that IP address, it's going to return the HTML template that we just created. Render template, render underscore template index.html. Close the parentheses. Okay, so now instead of coming back with a hello world, we should get whatever we did up here, my website, right? That's what we should get. This code makes Flash look for the index and the templates that the app.py program is in. Right? Make this file, make sure your app is still running. If it's not, run it again, use a terminal box. So we're going to do that. Okay, so then we're going to save this file. So over here on the left-hand side, Control O, Enter, Control X. And then I want to run the app again so that the app is running. And then if I come over here, I want to go back to the main web page and I should get my website. Yeah, so now I've got an HTML website running. And so I have an HTML website running on my Flask Python created web page, which is right this return using HTML page. Right now we have a challenge. I don't know. I may be in trouble now. We got to think. See what happens. I need a hint. I'm just going to go right to the hint. Now you know how to change your index page from HTML template. Make your cakes page use an HTML template too. Oh, okay. Sure. So we're going to do nano, nano cake, cakes.html. Right? We're on the right side. I'm not using the hints yet. I'm gonna try this without the hints. All right, and then I'm gonna go back a page here, and I'm gonna steal all of this mess, and I'm gonna paste this mess here, and I'm gonna go up here. I love cakes. I hope I don't screw this up. So, all right, and then Control O and Enter and Control X. I'm out of there, and then I'm going to go back over here to my web page, the terminal that I have the web page running on. I'm going to go ahead and kill the web page. I'm going to go into the app itself. Oh, I ran the app. I didn't want to do that. Control C. I want to edit the app, and then. You don't have to kill it? Okay.
No, you don't have to kill it at all.
All right, then I won't kill it next time. Thanks for letting me know. I think all I have to do is render underscore template. And then that and whatever I called it. Did I call it cakes? think I called it cakes. At cakes.html.
But if you want it to be a directory, you have to add the slash. No, you don't need it. Yeah, you can do that if you wanted. Yeah, that's fine. That's fine.
Is that okay?
That's right.
Okay. I did call it cakes, right? Okay. Just making sure. Control O, enter, Control X, and then we're gonna run that. And then over here, right? Cakes. Yes. Cool. That's how you do it. I'm glad this is recorded. We can watch this later. Templates in it. I went back. I got to go forward now. So I just created a template, right? And then I'll just look at the hints. Repeat the steps in the previous step, right? Yeah, good. And then cases. Yeah. Cool. I did
Yeah,
it.
I'm good with the yummy cake, you know.
Yeah, exactly, right? I love it. Okay, so we did it without, I did a challenge without actually looking at the instructions. That's pretty good. Again, not a web person. Add color, but I am a computer person, so I can pick up on this stuff pretty quick. Add color with CSS. All right, so now you'll add some cascading style sheets, right? So well, we're getting fancy. And I know we're not fancy, but still, right? Not a web guy. So make directory static. So is this in the same web app directory? Okay, so in the web app directory. So I'm not in the web app directory. So now I'm in the web app directory. There's my app.py, my template, and my templates. We're gonna make a directory called static. All right, create a new directory called static. Create a new file in idle called styles. And so this is going to be in the static folder. So we're going to cd to static. All right. And then nano, because I've been corrected, style.css. Beautiful. I love it. We could probably type that, but we're not going to. So the body, background red, color yellow. Easy enough. This code contains color names, but you can also create colors using the hex code. So if you have hex codes, you can do that. Save the changes. So Control O, enter, Control X. I think I can Control X and hit Y, right? Like that for enter. Then modify your index page. All right, so then in order to do that, I need to change. I got to go back up a directory. Right, and go into templates. Holy cow. So we'll change the index, right? So this would have been faster if I just typed in nano index, right? There's my index page. So I've got HTML. So I need to add, oh man, what am I doing? Just copy. Can I delete all that? I just gotta go here and delete everything. Right mouse click and paste. Oh, it's me and nano are not getting along right this second. Copy that, paste that. Okay, there we go. All right, so then this one added in the header and links to the style sheet, and we told it where to go to get the style sheet, which will change the colors, and then the rest of it was all the stuff we'd already done. This body. I guess I could have just added this top piece, right, to the total. Okay, Control O, Control X. Whoa, X. What was that? Permissions denied. I didn't do this as sudo. Or is it because I'm running the page?
Okay, so probably, I think that's one of the pages you created with sudo before. And when you create something from sudo, it's owned by root.
Okay, got it. So I,
Should have made it. So
yeah, so
Are
I'm
you
just gonna
editing it?
Control X. Yeah, but I edited it without using sudo. This is what's going on.
Yeah, if you use sudo the first time, you have to keep using it. Or you can change the permission on it.
Oh, yeah.
No,
First
I'm
time.
not gonna, yeah, I'm not gonna mess with it. I'm just gonna do exactly what I did before. And then all I really need from here is this piece here. Okay,
Wait. Stop. You got to get rid of the HTML on that line. No, the line you were just on.
oh, I see it. Thanks. Sweet, thank you. That one worked just fine. Save the changes and refresh your browser. Okay. And I'm not going to refresh. Well, I guess I'll refresh here. So there's my website. Awesome. Does that also affect the cakes folder too? No. That only applies. Oh, it's only in the index. My bad. I got you. It's only in the index. All right. If your web app doesn't look right, your CSS file might not be in the right directory. You have the number of files in the directory web app. So we've already done that. So static styles, templates, index cakes. Good. Awesome. So here's my cakes. And here's my index. Bright red. Adding dynamic content. Right. We can deliver static. Now that you know how to deliver static HTML, like I just know what you gave me. Hello world. So, all right. Large websites like yeah. So what are we doing here? We create a new route on your website so that you know when you go to here, the name says hello name. Replacing name with whatever you put in there. For example, hello data. So we're going to add the following code to create a new route in your application. So that's going to be, and that's going to set where I've got the app, right? So then, how did I get to app? Sudo nano index. Me and sudo. All right, let's go down to, I guess we're just going to put that one here. And then we got to, okay, so we're going to copy this out. So this is going to give us a new page, right? A new route. That's not the page. This is just the route to the page. And Control O, Enter, Control X. And then we need to go to our templates. And we need to create, I'm going to do sudo nano and everything because otherwise I'm just going to get confused. I know it's not the way I should have done it, but create a new template called page. Page.html. And we're going to copy this mess into it. So it's supposed to print hello and then whatever name we provide. Right? Oh, I'm confused. I was confused for a second because I'm like, why? Where did we make it as hello? We defined it as hello right there. So that's going to be where that's coming from. And then we're going to reference page. Okay, that makes sense to me now. Okay, Control O, Enter, Control X. I go over here and I put hello, and I think I just do that, right? Hello, Carrie. There we go. Cool. So hello is going to call the page. Carrie is going to, right, that's what it hands over the variable Carrie. Awesome. And they do explain kind of what's happening, but to me, I'm calling this page of this. I'm actually calling that route, right? Which gives me the page called page, and the page.page is looking for me to hand it a name so it can tell me hello. Create a link to your new dynamic hello page from your index page. Oh, is this where we would be able to create link? Like, yeah, hi, Paul is there.
So you could change it to Carrie.
I could.
Carrie. Okay, hi, Carrie.
All right, so then this is in the index page, which is upper level. Is it upper level? No, it's not. It's on this page. So then Nano index. .html. And everybody else is like, we're done. Why aren't you finished? Okay, so add the link under the heading. Right there. So caret a href equals quote /hello /Amy quote close the bracket. I think that's right. The colors look right. We'll go with that. All right. And over here, I want to go back to the main page, and I got the little hi Carrie, and I can click on it, and it takes me to hello Carrie. So that gets me thinking I could over here. Could I not? Could I take this piece?
Well, you can take Carrie, if you're trying to make a generic link, just take the word Carrie off.
Oh
And
no,
take it
what
out
I could you?
type in.
I want to link to Cake's page, right? So if I could I just do the same thing and then quote / Cakes, right?
Yep.
And then I would do the whatever I wanted to say.
Yeah, do a href equals cakes.
And then it's going to be /
Well,
Cakes, right? Like that.
Yeah, is there an equal sign there? Right
Yes,
before the
ma'am.
quote?
Yes, ma'am.
Then do a closing, yeah.
And then I
Cakes.
would whatever I wanted to be titled.
Yep.
Yummy cakes. And then I would closing like that.
And then do that closing BR tag. Otherwise it'll run
Oh
together.
yeah.
So, do
So
and then
this BR
BR and closing. You got it.
embedded cool. Control O, enter, Control X. And oh, look at that. 172, 69, 5,000. Yummy cakes. Love it. Look at that. Carrie's learning something new today. Okay, what's next? We saved it. We're done. I got multiple links on my deal, right? And then you got what next, right? So, add more CSS rules, create links to your favorite web pages, learn more about HTML, CSS, web development, right? So there's a bunch of places for you to go. There's some Flash documentation here. Oh, this would be cool. Create a physical computing project with Raspberry Pi using Flash to create a web interface to it, right? And Matt and Ben are awesome. So these, I would imagine these are probably really fun to do. So yeah, so we could actually take this page or this web page, right? And they could create like physical, like ways to connect to the, yeah, it does, doesn't it? Let's look at what Matt Richardson's guide looks like. Oh, wow. Okay. Saving Raspberry Pi with Flash. So worlds is a little, oh, look. Most of this is based on his thing, run host. So I'm under templates. Oh, look at that. This is old school. This is a 26 pin. This is one of the original Pis. And then here's a hello GPI. Oh, this would be cool. We got all kinds of time. Because this project's done, right? Most of the code is there already. That's kind of cool. And then I believe, let's look at Ben's, because it looks like it's bot code. Raspberry Pi photo tweeting web app for BET. So this is a photo tweeting web app. And imagine, here's your templates, here's your static, here's your styles. Index HTML and view. That's pretty cool. Right, so that's, I don't know, that's kind of fun. That makes it kind of like you're using, using a web page and then start creating. That's a new thing for me. I don't know, that seems, this seems really cool. So this is an excerpt from Getting Started with the Raspberry Pi. I happen to have that book right here. This is awesome. Anyways, what do you guys want to do? We can try this and see if we can get that. If you have physical computing components, we can give that a whirl. That's completely possible. We can move on to something else. We can go back to the processes. We can go back to the processes project as long as you didn't have to overwrite your add guard. Either way, any of those things, we can do anything brand new too as well. Because this usually never happens. I'm usually never an hour and 10 minutes. Usually I'm an hour and 10 minutes late. I'm trying to find the actual Python and the internet. There we go. Download data from a web server. Serving Pi via web server, Flash basics, connecting the web to the real world. I'm assuming that's the chapter that we're looking at.
What are we going to do tomorrow, and what do we need to have for tomorrow?
Tomorrow is this. MicroPython on the Arduino or the Raspberry Pi Pico.
Should we have a new Pi OS set up to connect to it?
I think we can take any of these Pis that we currently have, and I believe, let me look it up here. I believe all you need to do is add, well, no, we can do it with Thani. So we can program the Arduino, or not, I keep saying Arduino, we can program the Pico using Thonny on your Raspberry Pi. So you're going to connect the Pico to your Raspberry Pi, and we're going to program it from there. So as long as you, at that point, right, we're going to want to have a VNC connection to our device, right? So any of these servers that we just did, any of these things that we just played with, right? If you have 3 like I have, if you just have 1, as long as you have a Raspberry Pi that has an operating system that you can VNC to, then you're capable, you should be fine. So that copy was complete. So now I have a backup copy of my OS, right, that I can use if we have issues. Yeah, so we're just going to use Thonny here. We'll just follow the instructions and use Thonny so that you know, where to press and what to run and all that kind of stuff are on the same place. So yeah, that's all we need for tomorrow. Is that, well, that and your, right, your Pico kit that you picked up. It looks like we need LEDs. We're gonna need some buttons, a buzzer. We have, I don't know how far we get, or we'll see how far we get. Tomorrow I just wanted to play with the Pico. I've never played with it. I thought it'd be fun for us to play with. So I think we'll just kind of roll through this and see what happens. I'll gather up all the parts. So you can get this book. Let's do this actually. Whoops, not there. What am I doing? Let's go here and let's go to Mac. That was under Hackspace. Was it not? I believe it was. Under books.
It's on your MyIT page. It's on the MyIT instructor page.
Yeah, so I think I put it there because like this is what we're gonna do. I'm also gonna drop it into our Google Drive.
Got it. Did it.
Right, so Google Drive is there. So that's uploading now, but this is, right, so this is the book we're gonna use tomorrow, right? So, and it's gonna be, I don't know, I'm looking forward to it. I think it's gonna be fun. This will be it's kind of like just a different way of doing Arduino type stuff. We're gonna use Python the whole day. But we'll basically bring the book up like we do like this, right? And we'll kind of run through it and see what happens. Like this is all going to be new for all of us. Like I'll play with it tonight so that I'm not 100% new at it, but I literally got the box the other day, and we're not going to do any kind of soldering and stuff like that. So that's not, I already have headers on mine. Like this is what I've got. So that's what we're going to do. Yeah, so it'll be all Python, all playing around, all physical computing. So I think it'll be fun. I'm just kind of scrolling through to see, right, so I know there are, so that reminds me, so let's go out to that real quick. So so the materials list, so here's the book, right? The link to the book. And then these 3 kits, which, right, it's too late if right, you're not going to get it tomorrow. But the reason I picked them is that they were all designed to work with this kit, right? Which means they have, like, I don't have this little LED thing that you see right there. So, but it's also an appendix item. So this book being 138 pages, I seriously doubt that we're going to get through. We might, but I'm excited to try like that device, right? The LED panel. So buzzers, buttons, potentiometers, there's a motion sensor and a buzzer, right? And I think there's tons of projects for us to do throughout the day. So it's going to be really neat to try. I don't know. If you can't tell, I'm excited. I've been looking forward to this day for a long time. So, and I think you had mentioned, Katie, in an email, like this is the only way I get to do this. It's not like I'm gonna be able to crack open a day if I'm not like presenting a workshop. There's no way I was gonna be able to crack a day and play with a Pico, right? Because there's so many other things going on around us that have to be done. So
there's a new one that's supposed to be, it's a Raspberry Pi with a Connect on it. It's supposed to be like the Pico, but with the Connect quick connector.
Oh, okay. So there are, so yeah. So Who builds one? So SparkFun. So this, yeah, let's go to SparkFun. And let's go to, I'm not going to search Pico. What I'm going to search is RP 2040.
Yes.
Okay, so 2040, RP 2040, Raspberry Pi 2040 is the chip, right? The chip that's on these is the silicone that was designed and created by the Raspberry Pi Foundation. So this green Pico here, that is a Raspberry Pi product. This SparkFun microbus development board, that is a board developed by SparkFun that uses the RP chip, okay? I'm thinking this thing's plus one, right? Maybe what you're talking about. Yeah, there's the quick connect, right?
Yeah, SparkFun Plus.
Right, so the SparkFun Plus has the quick connect. It also is gonna require you to solder. So,
Right, but that's the whole point of using the Quick Connect
right,
is for people
you
like
don't
me
need
who
to
don't want to
solder.
solder, and I don't want to use the breadboard, and
Don't
I
use
don't
pins.
programming.
Yeah, that makes sense. That makes sense. Arduino Nano. So here's a Nano using the RP40. This is actually created. Is that Arduino that created that? It's got their logo on it. So they're using the RP chip there, and they put the pieces on. There's the power, but that doesn't have the quick connects. So the quick connects are the SparkFun ones, right? So here's also SparkFun Pro Micro. That's a quick connect, that's power. This is tiny. That's a little bitty guy. That's pretty cool.
So
Yeah.
could we take, you'll probably know this tomorrow, could we take, I hate to be the only one asking questions, but no one else speaks up.
I know, I feel like I'm kind of almost by myself.
So the quick, I'm here to learn. The Quick Connect is really cool, but even with the new Pico, the connector is, I want to get it to connect. Like, can you do that to a PC, or do you have to do it through another? Like, what adapter would you do to connect it to your PC?
It's a USB, right?
Okay, so you just plug it directly in. So I could do this. I could do this with even a PC as opposed to working with a Pi.
I think so, yeah. I think you can, you should be able to plug it in. I don't see why not. I mean, it's, yeah, so let's programming Pico from Windows, or sorry, my bad, Mac. Connect your Raspberry Pi to your Mac. So yeah, so here's somebody that walks you through. So download MicroPython, right? So MicroPython for the Pico, right? So there's, does it say where to get that from? Click on the tab, change these browsers to get started with Python section. So get started with the RP. So here's Raspberry Pi. We'll go back to the instructions. Look for the tab labeled Getting Started with MicroPython. Do you see a tab of MicroPython right there? And then on the MicroPython page, click on the tab. It should change the browser to Getting Started with MicroPython. Read the instructions, which should tell you to click on the download UF2 file. Right here, downloadable UF2 file. Or right there, download MicroPython. All right, so I'm gonna copy this page out to, so if you want to do this from your computer, this is, I don't think this is specific for Mac. I think this is pretty much any. Right. So there's a Pico SDK. RP2 quick reference. So this is the book we're going to use. You can program the Pico connect to your computer via USB cable, then dragging and dropping a file onto it. So we put together, okay, so UF2 file. So you program the file and just drag it onto the device. So there's gonna, I'll have to figure this out. I'll work on this tonight to figure out how this works from a computer standpoint. I download it. Well, let's do it right now. Why not? I don't know what, like, is that gonna work? Like push and hold the boot cell button and plug your Pico into the USB. Release the button after your Pico is connected. It will mount as a mass storage device. Drag and drop the MicroPython UF2 file onto the RPI2 volume. Your Pico will reboot. You are now running MicroPython. Wow. Okay.
Yeah, and I think Donnie will actually do a lot of that for you, because all I had to do was I didn't even read any instructions. I just plugged mine up to the computer,
Just
up
plug
to
it up?
Raspberry Pi,
Okay.
and loaded Donnie on Raspberry Pi, and it auto detected.
Yeah. So on the Raspberry Pi, it's designed to auto. Like it
Yeah,
works
it just
automatically.
went and did it, and I didn't have to do anything else.
Yeah. So this is if I want to do this from my computer.
Yeah,
Right,
I'm
so-
just thinking for students in the fall,
Right.
Picos are easier to get than Pis.
Yes. So that, yeah. So if you're gonna do like Arduino stuff, and then that's the other thing I just did with we're testing it right now. I sent a text over to one of my texts this morning. We're gonna dual boot our lab again with the Raspberry Pi desktop, so Windows and Raspberry Pi desktop, so that my students can buy, instead of buying a big kit, they can buy a Raspberry Pi Zero and then plug it into the computer and actually be able to do everything that we do. So I'm plugging in my Pico, and I just heard the ding in my, and they said it mounts as a, oh, it does mount as a, right, it mounts as a drive, and it's, does it say just, it says drag, mounts as a storage device, drag and drop. Okay, that seems odd, but let's do it. Oh, can't do it that way. Gotta have these windows where they're supposed to be. So drag and drop. Copy in the file. And it went away. And we're waiting.
When I practiced this in my classroom last week, I found like the steps you're demonstrating really straightforward. I had to like reboot the Pi 3 or 4 times before the Pi would recognize the Pico. That was where I had the issue.
Okay, so on the Pico, but on your computer, you didn't have a problem?
I only did it on the Pi.
Okay. So I dragged and dropped, and it went away. This doesn't say it mounts, drag and drop. Your Pico will reboot. It's now running MicroPython. You can access via USB. MicroPython documentation, step-by-step instructions. Nothing came back.
Yeah, it's definitely what happened to me with the Pi. I had to go into Thonny, and then I would see it as one of the options inside Thonny eventually after rebooting multiple times.
All right, so that's what I wanted to, yeah, we're just playing with this now to get ready so that we know what we're doing before we get there tomorrow. So it's on, no, it's not on. There's no indicator lights. I'll just hit the reset button. Curious if it will show back up. Like it seems like if I don't disconnect, it's not going to recognize it again. Does that make sense? And I don't see anything extra showing up on my screen here. Oh, I'm like, oh look, Donnie's up. I don't have, let me get rid of that. I'm confused myself. Close all these down, close all the tabs. There's nothing there. All right. So File Explorer, if I unplug the Pico and I plug the Pico back in, I'm thinking I need to, I'm thinking I need to have an editor, right? I think I need to have a Does for those that know Thani, does Thani have a Windows version? I think probably not.
I'm sure it does. I'm pretty.
Oh, it does
I'm
right
pretty
there.
sure It's open source. Oh, there it is.
So we're gonna put Thani on here. I'm thinking that, yeah, I don't think I have an environment that would connect to it. Cool, cool, cool. Give this a whirl. So Gary, how is it working? Are those working good?
Yeah, so far I had no problems wiring up the button, the LED, and
Nice.
I'm working on the LCD panel right now.
Cool.
I had a little bit of snag. I'm just trying to figure out if it's me or something else.
Okay.
You know, so that way, if something comes up, you know, at least maybe if other people hit it, I've already done it.
No worries. That's awesome. And you're running it from the Raspberry, right? Which was my original intent. So right now we're just trying to discover how to do this from other machines.
Yeah, so I'm running it from the Raspberry Pi. I have not tried it. I don't even have a Windows PC, so I couldn't try that.
Okay.
Um,
Oh, I
Mm.
didn't do this. So that's probably what's going on.
mm.
So that, yeah, so that got rid of, that put back as the, and then I can drag, oh man, I keep doing that, like it's not. Drag this over to here. It goes away. It doesn't seem to be acting like it's supposed to.
Um,
on the PC,
Thani?
on the PC.
Yeah. Have you tried this? Go to Thani, and on the bottom right of Thani, click on Python.
Oh, look at
and now
there.
you can select that.
Oh my gosh,
You're good.
we're good. We are connected. So it does work. All right then. Very cool. Now, I haven't looked, but there's got to be like a, does it have like a pin 13 LED?
Yeah, it does. I think is it saved as like a sample program or?
I wouldn't
Yeah,
know.
so there is a really quick script you can enter to test it.
Okay,
Let me find where that was.
If you go to file open, does it have sample programs?
Probably not.
probably
I
not.
don't
Yeah.
think it does. But if you look in chapter 4 of that book,
Okay. Yeah.
right at the beginning, it should have a really quick script. It's probably only 2 or 3 lines, let me think. Yeah, it starts off with import machine,
Got it. I see
and
it.
then 2 more lines to
Pin 25.
yeah, LED on board equals machine pin 25, machine
Okay.
pin out. Yeah, if you type just those 2 or 3 lines of code in,
Import machine.
you'll be able to see your light up.
Import time. And then LED underscore onboard equals machine dot capital pin 25 comma machine dot pin dot OUT. And then wow, true. LED underscore onboard dot value of 1 and utime dot sleep and onboard dot value, I would say 0 and utime okay. All right. Oh, right there, you see the LED, 5 seconds on, it's 5 seconds off right now. 5 seconds on. So if you just save it to the Pi or the Pico, it's just like sending a program to the Arduino, right? You just save it to the Pi, and then that's the Pico just runs that particular program. That's pretty cool. All right, cool. Awesome. Now that gets me thinking though. So it looks like the programming, does it start at chapter 5-ish? Chapter 4-ish, physical computing with Pico. Right, so yeah, so that's there. And then if we go back a little, okay. Homework. Chapter 1. You think you will worry about the soldering of headers at this point? MicroPython, installing MicroPython. I think chapter 2 is just kind of programming, which we'll do tomorrow. I'm not worried about that one either. chapter 3. All right. So the book that's, the digital book, if you don't have a physical one, if you have time, I think it would be helpful to read chapter 1. You can skip the parts about the soldering. Unless you bought one without it and you need to solder, then do go for it. But right, the guide, just kind of introduces the Pico, right? So this chapter 1, I can't even do it right. So introduces the Pico, and then chapter 3 introduces physical computing, but it doesn't have any coding, right? It's just talking about physical computing. So if you have a chance, I would go through those 2. And then we're going to start, we'll talk briefly about them, and then we'll start on chapter 4 tomorrow, right? Which is the code that you see on the screen right now is the first program in chapter 4. So it's UTime is right. That's just a library and it has sleep involved. I'd imagine, right? From UTime import sleep, I think you could. Can we get away with that? Oh. Right, and if we do it that way, I don't know if this is going to work or not. This is me playing around. I think I can get rid of this, right? And then whoever came up with this, right? I understand, wanting to be. We could just call it LED. Right? We don't need to be.
I suspect trying to do that with the sleep method's probably not going to work.
It might, and I don't know. So that's what we want to try. So we're going to hit that syntax error. Doesn't like something.
Mine too.
It doesn't like this one.
I use time instead of U time. Yeah.
Try taking out the word import after you.
Oh, this is supposed to be from.
Oh yeah.
Okay. Did it work?
So yeah, it's working. This whole 5
Nice.
seconds thing is ridiculous. Who in their right mind uses 5 seconds for a display so I'm going to stop that and then I'm going to hit play to see if we get any errors. No errors. And I'm getting a 1 second blink on my Raspberry Pi or my Pico. So that works. So the same kind of ideas, right? So UTime, I don't know if that's just a micro Python thing. But from UTime, the library UTime import sleep works just fine. I just changed the variable to LED. I think it makes sense, LED underscore onboard, just it's more descriptive, but right. We only have one LED that we're blinking and it's pin 25. I don't need to be writing out onboard. Yeah, so that works. So this is awesome because that makes, I think that's going to make the transition into Raspberry a whole lot easier, but we'll see. That's the whole point of tomorrow, is to kind of get in there and play with that. So, but if you get a chance, take a look at the book. The book, I've got a copy on our Google Drive. If you can go to my IT instructor and to our page that we have for this class, and it's one of the very first items up there. It's linked to get to the page. You can download the PDF from there. This is the stuff I'm talking about. It's just kind of, physical computing. So if you're comfortable with physical computing, that's going to be a really simple chapter. But if you've never done it before, then obviously probably a good idea. Check it out. This also is going to give us some other information that may be specific to the Pico, right? So how the pins break down and all that kind of fun stuff. It looks, they're not in the same format as they've done it 0 to 15 and then up to 28. So they're actually in a row, right? So one of the big things, everybody freaks out on the Raspberry Pi because all the pins are all out of order. So that's kind of cool. 3 volt, 3 volt. Yeah, we're good. Grounds, all kinds of grounds. Lots of good stuff. I think it's gonna be good. I'm excited. Other questions, other comments, other anythings? All right. Trying to go through the, make sure I didn't miss anything in the comments. Sarah, did you get your page to load on the?
I love what I did wrong.
Okay.
So what I found was, like, I don't like things running in terminal that I think are done, but they look like they're taking up space or something.
Right.
So I did a control X.
Like the app Pi running.
Yeah. So I did a little searching of like how to turn off Flask or, the server, and then I just rebooted. And then it worked fine. So I will no longer try to close things that should, or stop things that should be running.
From and I don't know if it works on this one, but from the exercises yesterday, we didn't get that far. We didn't get to this point in the exercise yesterday, but there is right, there's a command that you can run that will, like right now, the way it's written, if you write Python, right, Python app.py, it runs and it takes up the terminal, right? And you can't use the terminal. And if you X out of the terminal, you kill the program, right? There's a command that you can run like I want to say it's like no hub, H. Why did I just lose it? Where is it? So there's a command in this program. I'm looking for the right picture. Why am I? Oh, here's a system decimal. Let's go this one. Monitor your Pi. So, and I'm wondering, we could probably try to run the app with this command to launch a monitor process. So actually, monitor a process. So right here, right? So this is what we, run monitor process.py, and then it hangs up that terminal, right? It's just like the web app. So, but if you, this one is no hub. Is anybody familiar with this? No hub, right? If you run that, right? And I don't know if you need this or not, but it allows you to run it and it returns you to the command prompt, but it runs in the background, right? And it doesn't.
Yeah, so you can actually omit no hub if you're just doing it temporarily and want to have it in the background.
Okay.
As long as you're logged in. The ampersand is the thing that actually sends it to the background.
That sends it to the background. Okay, so
No
if you
hub
just
means no hang up, and it's one of those commands that dates back to the 70s and 80s, right?
the
So we had
beginning,
dial-up,
right? way back when stuff got
don't end it when there's a hang up. No hang up.
Yeah.
No hub.
Okay, so then you could, sounds like you could run, Python 3 space web app.py space ampersand, and it will run in the background, right? And then that way, it doesn't, if you kill the terminal, it will kill the program, right? I'm pretty sure.
Yeah, I thought I was like being efficient and saving space.
No.
It shows how little I understand.
That one we're running Python in a terminal. we need it to be there.
Yeah. If you have no hub, then even if you log out completely in the terminal, it will continue running.
Continues running. So if you want it to run, so the point of this one, we want the Python monitor to run all the time, right? So that's why we did it this way, or why we would have done it that way if we got it to work. We got stuck here, right? Where we had all the failures, right? But this way here runs it like AdGuard, like you'd want to run no hub with AdGuard, right? So then AdGuard runs, well, AdGuard's a web page, right? So it runs in the background anyway. So, but a Python program like web app, like you want the page to be running all the time, no matter what you're doing, then that would probably be the process. So I'm kind of surprised that it wasn't, maybe, I don't know, it wasn't included in the tutorial, but that would have been a really good piece to add to the tutorial.
So I have a question for the group. with the Pico, when the Pico's attached, connected to the Pi, can you see the Pico in File Manager?
For those that have done that. Can you, once you, I don't know, I can plug it in. Let me plug it in on mine. We'll see what happens.
Yeah, I don't have my GUI up right now, so I haven't even looked at that.
Yeah, I haven't tested it either.
Okay.
106. All right, I'm gonna unplug it from my current computer.
That's my tonight's homework.
There you go. Play with it. Okay, so there we go there. Programming Thani. Oh, that's really big. I need to adjust the. Does it have the same thing over here? Yeah, there's the Pico. And then if I click on, so it shows up in Thani. If I click here, it would show up. Wouldn't it show up here? It's not showing up here. Or it show up under mount? Nope. I think it usually shows up under media if it's going to show up.
Okay, so it could be that Donnie has complete control of it right now. So another question would be, if Donnie's not running and you remove it and insert it, would it show up then?
Okay, let's do that.
Under Pi, under media and Pi.
Is the file system loaded or is there an actual file system on the Pico?
I think it's like a flash thing. Like you just send you send the one program just like you would an Arduino, and it runs that one program.
Got it.
Is my understanding of how that functions. I want to check here if I plug in an SD card. This thing should recognize it shortly. So I'm thinking on the Pico, it doesn't show up on the Raspberry as it's not going to show up as a storage device.
I'm showing up here the device on the desktop, and it also has 2 files in it.
Okay.
Index
So,
HTML, which takes you out to related info about it itself.
this is interesting because I just plugged. Am I not on the right machine? Which machine am I on? I thought I was. Okay, so nothing's showing up here. That one. No, this is the new one. Lost. Like I got multiple machines. I'm like, did I plug into the right computer? I did. But what's interesting is that the thumb drive didn't recognize properly either, which is weird because it normally pops right away and then does show up in the media section. So for some reason, there's something weird going on. The drive was removed without rejecting. So it knew it was there, but it wasn't presenting it to me. Normally this gives me, oh, maybe my screen is too crazy for that. My screen is way too big. Let me. Really? And now that goes away. What happened to my, ability to change my. Oh my. It's missing. There's no way to change the resolution. We just installed this computer like an hour and a half ago. What happened? That's crazy.
So I just moved the Pico to different pies that are, you know, connected now that I understand SSH. And it each time the Pico is immediately recognized and there are no issues at all.
Right.
Inside Thonny.
Yeah. It's designed. I mean, it's already, it's one of those, it's one of those kind of Apple things, right? All Apple stuff works together. All Raspberry Pi stuff works together.
Yeah, just that first day I set it up, it took quite a few times. So
okay.
I'd like to know, curious why, but.
Why it was acting like that?
Yeah, but I think I'm going to say goodbye. See you tomorrow,
Okay.
everybody.
Sounds great. Have fun. Yeah, so for those that need to go on and do other things, we're done about a half hour early. Right, and we've got, looks like we've got the, you know, we've got the Pico connected, and I can send programs to it, and so we'll be in good shape there. But if you have a chance, take a look at the MicroPython book 1 and 3, the 2 chapters. That just to get a little sense of what it is and what we're going to do. You're obviously welcome to kind of work through other things. But we're going to work through starting with chapter 4, and I'm just going to work through the book because I want to see what the book is and what it does and what it teaches. And then we can kind of, as we do that, you can kind of look at what may work for you, what may not. My idea of having the Pico is to, first of all, it's a $4 device versus a $20 Arduino. And it connects to the Raspberry. So we would basically fire up Raspberries and we'd be able to, you know, students be able to connect that way. Plus, in my lab, I'm putting the Raspberry Pi desktop on the PCs. So then I'd be able to connect to the Raspberry Pi desktop with the Pico, and then also have them switch over to, say, maybe the Raspberry Pi Zeros. Again, trying to find a way to reduce the cost currently, to give them more options to play with things and learn things. I think we're going to lose, we're going to lose a little bit of performance and things like that with that, but I think the end result will be a little less investment from the student side as far as equipment is concerned, and maybe a little bit more excitement in how it functions. This is nice too. I love this, that we're actually right off the bat, right into, we're not copying scripts over, right? Because I guarantee you with doing the Tinker Kit the way we do the Tinker Kit, my students learn absolutely no programming as part of that assignment, unless I give them the challenge exercises, and then they have to kind of dig into it. So I'd rather kind of go this route where we have to type out the code and type in, right, the Python coding into the interface, because then at that point we're doing Python from day one. So then the Python lessons that they take, the Python they do with Pico, the Python they do with Raspberry, they all work in conjunction with each other. So anyways, that's my thinking. Tomorrow we will get into and play with Pico. All right. Other than that, I hope you have a great day. We got things to work today. It was awesome. We made 2 websites. Talked about a lot of really cool magazines this morning. Got an idea. I'm gonna start building out a server rack for my Raspberry Pis at the school. And maybe one of these days we'll have an official, get together and check out the lab event. I think that would be really fun. Excellent. Take it easy. Have a nice evening. I think everything else here looks pretty good.
All right, man. Thank you. Great work. So
My pleasure. My pleasure. Have fun.
All right. Take care, buddy.
Yep.
Bye.
I'm going to stop the recording at this point.